All right, so we're transitioning from when something hits the ground to when something is going to be at its maximum, that's its highest point, or its minimum, its lowest point. We're going to mostly do maximums, but there are a couple other times when we look at minimums. You want to minimize cost in business ventures. So when we find a maximum or minimum, it's really important that you understand two things. One, you have to determine, right, look at your question. So step one right here, look at your question and determine what each variable is going to represent in the context, right? So typically, you're going to see that x is going to represent time again if it's something that's flying through the air, and y is going to represent height. There are, with our business questions, they're going to be a bit different. But the first thing you're going to want to do then is to find the axis of symmetry. That axis of symmetry is the when. It's the when something happens. And then just like we've been doing in the last couple lessons, we're going to take that axis of symmetry and substitute it in. We're going to plug it in to figure out the y value. That's the actual how high. So let's jump into this example. And it's a two-part thing because the first part is to find the when. How many seconds before Jason reaches his maximum height? He's jumping off of a cliff here into some water, right? And then so how many seconds, the when, and then what was that maximum height? When did it happen first? And then what was it? So let's start by looking at our equation. Our equation's right here. And to find the when, that's the axis of symmetry. So if you forgot, our axis of symmetry is the opposite of b divided by 2 times the a value, right? You take the opposite of b divided by 2 times the a value. So in this particular case, our axis of symmetry is the opposite of 32, so negative 32. And then we divide that by 2 times negative 16. So what this actually works out to is negative 32 over negative 32. Nice and easy. 1. So it's actually 1 second, right? It takes 1 second after Jason jumps, and that's going to be when, how long, when he gets to his maximum height, right? Because if we think about Jason jumping off of his cliff into the water here, we'll say that's Jason in our cliff. When you jump, right, you go up just for a second, right? You get to that maximum height right away, and then the rest of it is on its way down, right? So now we want to figure out part B, what that maximum height actually is. So we take the 1 second that we found and we plug it back in to the equation, right? We plug it back into the equation that we were given. So if we plug it in, everything stays the same, except we just leave a blank where the t's were, right? Because we're about to plug in a number there. Now you're going to see that Jason is jumping off of a pretty high cliff. So this is not recommended. Do not try this at home. But if we were to plug in 1 here, 1 squared still 1. 1 times negative 16 still negative 16. 1 times 32 is still 32. And then plus 480. So when we add all this together, negative 16, that curly Q got a little crazy. Negative 16 plus 32 is 16. So when we add that together, add that to the 480, we're going to be left with h equals 496 feet. So I do not recommend jumping off of a cliff that's 496 feet tall. Please don't go try that anywhere, right? Your cliff here, though, the maximum height of our jump is going to be that 496 feet. So that's the process that we're following. We follow the when, and then we find the how high. Let's immediately jump into another one. Opposite of b would be, in this case, 128. So x equals negative 128 divided by 2 times negative 16. So in this case, that's negative 128 divided by negative 32 again. And when you divide negative 128 by negative 32, we're going to be left with 4, right? So that means that our rocket, our toy rocket, gets to its maximum height after 4 seconds. after 4 seconds. Now that we know when that time is, we take that time and we plug it back in to t. So negative 16 times something squared plus 128 times something again. And one more time, we're going to plug in that 4 into the parentheses. 4 and 4. Got to do exponents first. So 4 squared is 16. So we have 16 times negative 16. Okay. Plus 128 times 4. Let's just go ahead and multiply those. 128 times 4 is 512. All right, 512. And then 16 times 16 is 256, so negative 256 plus 512. And guys, remember, this would be non-calculator. We would expect to be able to figure these multiplication and this addition and stuff out. But when we add negative 256 with 512, that's actually just half of it. So it's going to end up being positive 256 feet. So our toy rocket gets to a maximum height. That's our maximum. Our maximum height is 256 feet. So I hope you're starting to see how the maximum height questions are different than the when does something hit the ground questions. We're going to do a couple more and then we're going to call it a day.